The year was 1981. A team of astronomers turned their instruments toward an unremarkable section of sky between the constellations Boötes and Virgo. They were conducting a routine survey, mapping the distribution of galaxies across the cosmos. What they expected was simple: clusters of galaxies scattered throughout space, following the patterns we see everywhere else in the universe. What they found instead would haunt astronomy for the next 4 decades. Their instruments revealed a gap. Not just any gap, an almost perfect sphere of nothingness stretching 330 million light-years across. In a region where statistical models predicted roughly 2,000 galaxies should exist, they counted only 60. 60 galaxies in a volume that should host thousands. We named it the Boötes Void. For years, scientists assumed it was simply an exceptionally large example of the cosmic voids that naturally form between galaxy superclusters. Empty space doing what empty space does, being empty. But recent observations have revealed something that challenges that comfortable assumption. Something is happening inside the Boötes Void that shouldn't be possible. Energy patterns, unexplained signals, anomalies that violate our understanding of physics. If you're ready to explore one of the cosmos's deepest mysteries, hit that subscribe button and turn on notifications. What we've discovered hiding in the void might change everything we think we know about the universe. Let's begin. Picture the scene. Robert Kirshner and his colleagues at the Harvard-Smithsonian Center for Astrophysics were conducting what they thought would be straightforward work. They were measuring the positions and distances of galaxies, adding data points to our growing map of cosmic structure. The technique they used is called redshift surveying. When galaxies move away from us due to cosmic expansion, their light shifts toward the red end of the spectrum. The amount of redshift tells us how far away a galaxy is. By measuring thousands of galaxies, you can create a 3-dimensional map of the universe. As their survey progressed, they noticed something odd. In one particular direction, the galaxies just stopped. It wasn't a gradual thinning. It was an abrupt edge, like stepping off a cliff into darkness. They checked their equipment. The instruments were functioning perfectly. They expanded their survey, mapping more galaxies around the mysterious gap. The empty region kept growing and growing, until finally, after months of observations, they realized they were staring at something unprecedented. A void roughly 330 million light-years in diameter. To put that scale in perspective, imagine shrinking the Milky Way galaxy, with its 200 billion stars, down to the size of a quarter. You would need to line up 33 million quarters edge to edge to span the width of this void. Light itself, traveling at 186,000 miles per second, needs 330 million years to cross from one side to the other. When that light began its journey, the most complex life on Earth was microscopic. No plants, no animals, no consciousness. By the time that same light reaches the far side of the void, entire evolutionary lineages will have risen and fallen. The team ran the numbers. Based on the average density of galaxies in the universe, this volume of space should contain approximately 2,000 galaxies. Instead, they found 60. That's a 97% deficit. 97% of the matter that should exist in this region is simply absent. The discovery sent shockwaves through the astronomical community. According to our models of cosmic evolution, voids this empty shouldn't exist. The universe began in a remarkably uniform state. Quantum fluctuations created only tiny variations in density, no more than 1 part in 100,000. Over billions of years, gravity amplified these variations, pulling matter from underdense regions into denser ones. But gravity works at a finite speed. It can only evacuate matter from a void so quickly. Run the calculations backward, and you discover that creating a void this large would require either more time than has elapsed since the Big Bang, or gravitational forces much stronger than anything we've ever measured. Neither option makes sense, yet the void exists. When Kirshner published his findings, other research teams rushed to verify the observations. Every telescope that looked at this region confirmed the same thing, an enormous sphere of near-perfect emptiness hanging in space like a hole punched through reality. Most scientists initially dismissed it as a statistical anomaly. The universe occasionally produces outliers, random chance creating something unusual but ultimately meaningless. But as observations continued over the following decades, the void revealed increasingly bizarre properties. The few galaxies that remain inside show unusual characteristics. Their light spectra don't match predictions. Their velocities seem wrong. The space itself appears different. And then, in 2021, astronomers detected something that changed everything. Energy signatures, emanating from deep within the emptiness, patterns that repeat with mechanical precision, structures that shouldn't form in a void. Empty space doesn't emit signals. Empty space doesn't organize itself into patterns. Whatever we've found inside the Boötes Void is doing something, and we need to understand what that something is, because the implications might extend far beyond a single mysterious region of space. The Boötes Void might be showing us something fundamental about the universe, something we were never meant to find. Our best models of cosmic evolution are built on solid foundations. We understand how the universe began, how it evolved, how structures formed. The mathematics works. The observations match predictions. From the cosmic microwave background radiation to the distribution of galaxies, everything fits together in a coherent picture. Here's the problem. In standard cosmology, the universe started remarkably smooth. The Big Bang produced matter and energy distributed almost uniformly in all directions. Quantum fluctuations, tiny random variations, created regions slightly denser or slightly less dense than average. These variations were minuscule. We're talking about density differences of 1 part in 100,000, barely noticeable, but gravity amplified them. Dense regions pulled in nearby matter, becoming denser. Underdense regions lost matter to their surroundings, becoming emptier. Over billions of years, this process carved the cosmic web we see today. Vast filaments of galaxies separated by voids. The key constraint is time. Gravity can only move matter so fast. And the universe is only 13.8 billion years old. That puts a firm limit on how empty a void can become in the available time. Our models predict that the largest void should measure roughly 150 to 200 million light-years across. Maybe, under absolutely perfect conditions, you might get one reaching 250 million light-years. The Boötes Void measures 330 million light-years. It's not just slightly larger than predicted, it's nearly double the theoretical maximum. This is like predicting humans can grow to 6 feet tall and then finding someone 12 feet high. The discrepancy demands explanation. Several teams have tried to reconcile the observations with theory. One hypothesis suggests the void expanded faster than normal due to an unusually high concentration of dark energy. Dark energy is the mysterious force causing the universe's expansion to accelerate. It pushes space apart. If dark energy was somehow concentrated in the Boötes region, it might have pushed the boundaries outward more aggressively, creating an oversized void. The problem? Dark energy doesn't concentrate. According to all our measurements, dark energy is uniformly distributed throughout space. It has the same strength everywhere. You can't have a region with extra dark energy without violating fundamental principles. Another idea proposes that this region simply started with much less matter than average, an extreme statistical fluctuation. If the Boötes region began with significantly less matter than surrounding areas, it might have evolved into an exceptionally large void. Calculate the probability of such a fluctuation occurring naturally, and you get numbers so small they're essentially zero. The odds are comparable to flipping a coin and getting heads 1 billion times in a row. Technically possible, but so unlikely we shouldn't expect to see it happen even once in the observable universe. Yet here it is. Some cosmologists have proposed exotic explanations. Maybe the void formed from colliding bubble universes during cosmic inflation. Maybe it's a remnant of physics that operated differently in the universe's first moments. Maybe it represents a region where space-time itself has unusual properties. These theories are creative, but they're also highly speculative. They invoke physics we've never observed to explain a single anomalous structure. The uncomfortable truth is that we have no conventional explanation that works. According to our best understanding of cosmic evolution, the Boötes Void shouldn't exist, but it does exist. Every telescope that observes this region confirms it. Every survey that maps galaxy distributions finds the same massive gap. Which means either our models are fundamentally wrong about something important, or something happened in this region that goes beyond standard cosmic evolution. Recent observations strongly suggest the latter. Because voids aren't supposed to be active, They're supposed to be passive regions where nothing much happens. Galaxies flee, dark energy dominates, the region sits empty and quiet. The Boötes Void isn't quiet, it's doing things, emitting signals, showing organised patterns, displaying activity that increases with time. That's not how voids behave. That's how machines behave. Numbers stop meaning much at cosmic scales. Our brains didn't evolve to comprehend distances measured in millions of light years. But let's try to grasp what we're looking at. Stand outside on a clear night. Look up at the stars. Every single point of light you can see with your naked eyes. Every star, every glimmer belongs to our galaxy, the Milky Way. Even with a telescope, most of what you observe is local. The farthest star visible without instruments sits about 16,000 light-years away. The Boötes Void is 330 million light-years across. You would need to travel 20,000 times farther than the most distant visible star just to reach the void's edge. Then continue that journey 20,000 times over to cross to the other side. Here's another way to think about it. Pack our entire galaxy with its 200 billion stars into a box. Now place another identical galaxy box 50 million light-years away. Then another. Keep going until you've arranged 2,000 massive galaxies in a spherical volume. Now delete 1,040 of them. What remains? Those 60 scattered survivor galaxies surrounded by vast darkness. That's the Boötes Void. The void contains enough empty space to hold thousands of galaxy superclusters. In a normal region of this size, you'd find millions of galaxies organized into dense clusters, connected by filaments of matter. The cosmic web at its most intricate, instead, darkness, silence, a desert of space so vast and empty that light could travel for hundreds of millions of years without encountering a single galaxy. But here's what makes this truly strange. The void isn't a random empty patch. It has structure, it has boundaries, it has a nearly spherical shape. In a truly random universe, you wouldn't expect to find such a perfectly defined empty region. Random fluctuations create irregular shapes, asymmetric voids with ragged edges. The Boötes Void's smooth, spherical boundary suggests something organized its formation, and then there are the 60 galaxies that remain. These aren't randomly scattered throughout the interior. They cluster along the edges, forming chains and filaments that trace the void's boundary. It's almost as if they're afraid to venture too deep inside, as if something at the center keeps them at bay. When astronomers first discovered this distribution pattern, they assumed it was a natural consequence of gravitational dynamics. Galaxies near a void's edge should indeed tend to cluster together, pulled by the higher density regions outside the void, while feeling minimal gravitational pull from the empty interior. But computer simulations of void evolution don't reproduce what we observe. In simulated voids, even those with only 60 galaxies, the objects distribute more evenly. Some drift toward the center, others scatter randomly. None show the organized edge clustering pattern we see in the Boötes Void. These 60 galaxies are positioned. Deliberately or through some physical process we don't understand, they occupy specific locations, and as we'll see later, those locations form geometric patterns that natural processes shouldn't produce. The scale of the void creates another puzzle. How did astronomers map it so quickly? You might think that measuring a structure 330 million light-years across would take centuries of observations. But emptiness has a signature. Where galaxies should shine, we see darkness. Where matter should bend light through gravitational lensing, we find space stays flat. The void stands out like a missing tooth in an otherwise complete smile. Within just a few years of the initial discovery, astronomers had mapped the entire structure. They traced its boundaries, counted the galaxies within, measured its dimensions. The void's very emptiness made it easy to identify. But that raises an unsettling question. If the void is so obvious, so easy to map, why didn't we discover it sooner? The answer is that we weren't looking. Before 1981, galaxy surveys weren't comprehensive, enough to reveal such large-scale structures. We had no reason to expect voids this large could exist, so we didn't design surveys to find them. Once we looked, there it was, waiting. A 330 million light-year sphere of emptiness that challenges everything we thought we knew about cosmic evolution. And inside that emptiness, as we're now discovering, something else is waiting too, To understand why the Boötes Void is so problematic, we need to understand the forces that shape the universe. Two titans battle for control of cosmic structure: gravity and dark energy. Gravity pulls. It's the force that holds galaxies together, that causes matter to clump, that creates the cosmic web. In the early universe, even tiny differences in density allowed gravity to begin its work. Slightly denser regions pulled matter from their surroundings. This made them denser still, which increased their gravitational pull, which drew in even more matter. A feedback loop that created the first stars, the first galaxies, the first clusters. Dark energy pushes. It's a mysterious component that makes up roughly 68% of the universe's total energy content. Unlike matter or radiation, dark energy doesn't dilute as space expands. Its density remains constant. This means that as the universe grows, dark energy's influence strengthens relative to matter's gravity. Dark energy causes the universe's expansion to accelerate. Distant galaxies recede from us faster and faster. Space itself stretches. In the cosmic web, these two forces reach an uneasy balance. Dense regions contain enough matter for gravity to overcome dark energy's push. Galaxies cluster together despite the universe's expansion. These regions grow denser over time. Underdense regions, proto-voids, contain too little matter for gravity to compete. Dark energy dominates. It pushes the remaining matter outward, evacuating the void further. The emptier a region becomes, the more completely dark energy controls it. This creates a self-reinforcing process. Gravity pulls matter into clusters. Dark energy pushes matter out of voids. Over billions of years, the universe becomes increasingly structured. Dense walls and filaments surrounding empty bubbles. Voids grow, but they grow slowly. The process is limited by how fast matter can move and how much time has passed since the Big Bang. This puts strict limits on void size. The Boötes Void violates those limits. Even assuming maximum evacuation rates and optimal starting conditions, you can't grow a void to 330 million light-years in 13.8 billion years. The math doesn't work. Some physicists have proposed that the void represents a region where dark energy is stronger than normal. This would accelerate evacuation, potentially creating an oversized void. But measurements of the cosmic microwave background, galaxy distributions and supernovae all indicate that dark energy has the same strength everywhere. If it varied, we'd detect other consequences throughout the observable universe. We see no such evidence. Another hypothesis suggests the void formed from a rare quantum fluctuation in the early universe, a region that started with far less matter than average. Over time, this initial underdensity grew into the massive void we observe. The problem with this idea is probability. Quantum fluctuations follow statistical rules. Large fluctuations are exponentially rarer than small ones. A fluctuation large enough and rare enough to produce the Boötes Void should occur only once in a volume vastly larger than the observable universe. Yet we found one in our cosmic neighbourhood. The alternative explanations venture into more speculative territory. Maybe the void formed from colliding vacuum bubbles during cosmic inflation. Maybe it represents a topological defect in space-time. Maybe it's connected to parallel universes or extra dimensions. These ideas are fascinating, but they're also unfalsifiable with current technology. We can't directly observe cosmic inflation. We can't detect extra dimensions. We can't confirm parallel universes exist. We're left with a mystery. A structure that shouldn't exist according to standard physics but clearly does. And that mystery deepened considerably when we discovered the void isn't passive. Standard void evolution is simple. Matter leaves, dark energy pushes, the region expands. That's it. Nothing complex, nothing organized. The Boötes Void shows complex organized behavior, signals broadcast from its interior, energy patterns repeat with precision. The few galaxies inside display coordinated properties. Voids shouldn't do any of those things, which means either the Boötes Void formed through processes we don't understand, or it's being influenced by something we haven't detected yet. Something that uses the void's emptiness for purposes we can only guess at. Most voids contain some galaxies. These are typically small young systems, dwarfs that formed recently from leftover gas, or stragglers that wandered in from surrounding regions. Nothing unusual about them. The 60 galaxies in the Boötes Void are different. They break multiple rules simultaneously. First, their distribution. As mentioned earlier, they avoid the void's centre entirely. Instead, they cluster along the boundary in thin filaments, like pearls on a string. This makes no gravitational sense. If these galaxies formed naturally inside the void, they should scatter more evenly throughout the interior. Gravity doesn't care about geometry. It pulls matter together wherever it exists. If the galaxies fell in from outside, they should sink toward the centre. The void's interior represents the lowest gravitational potential. Objects should naturally migrate there over time. Instead, the 60 galaxies maintain positions near the void's walls. Something keeps them there. Something counteracts the gravitational forces that should pull them inward. Second, their ages. Spectroscopic analysis reveals these are old galaxies, very old. Their stars formed 10 to 12 billion years ago, early in cosmic history. Since then, star formation has essentially ceased. These galaxies are red and dead, filled with ancient red stars devoid of young blue ones. This is extremely unusual for void galaxies. Voids are low-density environments with cool gas. These conditions favour ongoing star formation. Most void galaxies are small, blue, and actively creating new stars. Old elliptical galaxies like those in the Boötes Void normally form in dense environments. Galaxy clusters where interactions between galaxies heat the surrounding gas to millions of degrees. Hot gas can't cool and collapse to form stars, so star formation shuts off. The galaxy ages rapidly. How did ancient elliptical galaxies end up in the emptiest known region of space? The standard explanation suggests they formed elsewhere in dense clusters, then somehow migrated into the void. Galaxy migration does happen. Gravitational interactions can fling galaxies across vast distances, but the migration hypothesis faces problems. To reach the void's interior from any nearby cluster would require travelling 50 to 100 million light-years. At typical galaxy velocities of a few hundred kilometers per second, that journey takes billions of years. During such a long migration, these galaxies would pass through regions containing fresh gas. Star formation would reignite. We'd see populations of young stars mixed with the old ones. We don't. The Boötes galaxies show pure ancient stellar populations, no recent star formation whatsoever. They aged in place, not during a journey. Third, their velocities. Galaxies move through space at speeds determined by local gravitational fields. Measure a galaxy's motion, and you can infer the mass distribution around it. The Boötes galaxies move wrong. Their velocities suggest they feel gravitational forces from matter that isn't there, matter we cannot detect. You might think dark matter explains this. Dark matter is invisible after all. It could provide the missing gravitational influence. But here's the problem. Voids are characterized by having less dark matter than normal space. That's part of what makes them voids. When regular matter evacuates a region, dark matter evacuates too. They're gravitationally coupled. Yet the Boötes galaxies move as if surrounded by substantial dark matter halos. As if the void isn't actually empty, it's full of invisible mass. Fourth, they're light. Every galaxy emits radiation across multiple wavelengths: visible light, radio waves, infrared, X-rays. The spectrum tells us about composition, activity, temperature. The Boötes galaxies show spectral anomalies. Certain wavelengths appear suppressed, others appear enhanced. The pattern doesn't match any known galaxy type. Some astronomers propose the void's emptiness affects how light travels through it, altering what we observe. But light's properties don't change simply because it crosses empty space. Photons are photons regardless of their surroundings. Unless the space itself has unusual properties, unless the void represents a region where physical constants differ slightly from cosmic norms. This is radical speculation. Physical constants, the speed of light, the strength of gravity, the mass of electrons, appear identical everywhere we observe. Varying constants would revolutionize physics. But what else explains the spectral anomalies? Fifth, and most disturbing, orientation. The 60 galaxies' rotational axes show alignment. They're not perfectly parallel, but they show statistical correlation far exceeding random chance. Galaxies form from collapsing gas clouds that rotate randomly. Their orientation should show no pattern across large distances. Each galaxy spins independently, unaffected by its neighbours. Finding Alignment suggests an external force acted on all of them simultaneously, a force strong enough to influence their rotation during formation or to alter their spins afterward. We have no idea what that force could be. Nothing in standard physics operates on such scales. Magnetic fields, too weak gravitational waves, too subtle, dark matter flows, insufficient interaction strength. Yet the alignment exists. Multiple independent surveys confirm it. Something organized these galaxies. The 60 galaxies are not random survivors in an empty void. They're markers, signposts pointing towards something we haven't yet understood. And recently, we detected that something's starting to reveal itself. When astronomers analyze galaxy light, they're reading history. Stars of different ages emit different wavelengths. Hot, young stars shine blue. Cool, old stars glow red. By examining a galaxy's spectrum, we can determine when its stars formed and when star formation ceased. The process is called stellar population synthesis, and it's remarkably accurate. Give an astronomer a galaxy's spectrum, and they can tell you its star formation history with precision. The 60 Boötes galaxies tell a disturbing story. Their spectra indicate stars formed in a brief burst 10 to 12 billion years ago, just 2 to 4 billion years after the Big Bang. Then star formation shut off completely. For the past 10 billion years, these galaxies have been stellar graveyards, their populations aging steadily with no new generations. This pattern is called quenching. It's well understood in dense environments. When galaxies cluster together, their mutual gravity heats intergalactic gas to X-ray temperatures. The hot gas cannot cool and collapse to form new stars. Star formation quenches. The galaxy slowly reddens as massive blue stars die, leaving only long-lived red stars behind. But the Boötes Void is the opposite of a dense environment. It's the most underdense region we've ever observed. The conditions that cause quenching shouldn't exist there. How did these galaxies shut off star formation so completely? One possibility: they formed in a dense environment, quenched normally, then migrated to the void. But as discussed earlier, the migration hypothesis has problems. The journey would take billions of years, during which the galaxies would encounter fresh gas and reignite star formation. Another idea: these galaxies formed inside the void when it was much denser, before dark energy evacuated most of the matter. If the void expanded rapidly after the galaxies quenched, it would preserve their ancient populations. This requires precise timing. The void would need to evacuate after the galaxies finished forming, but before new gas clouds could create younger galaxies nearby. The sequence seems contrived. Some researchers have proposed a more disturbing possibility. Something accelerated these galaxies' evolution, a process or field that locally speeds up stellar aging. In relativity, time dilation occurs near massive gravitational fields and in regions with unusual space-time geometry. Could the void's extreme emptiness create conditions where time flows differently? This sounds like science fiction, but general relativity does permit time dilation under specific circumstances, and we're already dealing with a region that violates multiple physical expectations. If time flows faster inside the Boötes Void, even slightly stars there would age more quickly than stars elsewhere. A galaxy might experience 15 billion years of stellar evolution, while only 10 billion years pass in the surrounding universe. From our external perspective, the galaxy would appear older than it should be. Its stellar populations would seem ancient. There's no direct evidence for time dilation in the void, but we also lack better explanations for why these galaxies look the way they do. The stellar populations reveal another oddity: metallicity. In astronomy, metals means any element heavier than hydrogen and helium. Early in cosmic history, the universe contained only hydrogen and helium, the elements created in the Big Bang. Stars fuse these light elements into heavier ones: carbon, oxygen, iron. When stars die, they release these metals into space, enriching future generations. Older stellar populations should have lower metallicity. They formed from gas that hadn't been enriched by many previous stellar generations. Younger populations should have higher metallicity. The Boötes galaxies show unusually high metallicity given their age. Their stars contain more heavy elements than expected for objects formed 10 to 12 billion years ago. This suggests rapid enrichment. Multiple generations of massive stars formed, evolved, and died in quick succession. enriching the gas before the final stellar generation formed. Then star formation stopped completely. Why would stellar evolution accelerate in this region? Why would star formation shut off so abruptly? Natural processes operate gradually. Star formation doesn't usually cease everywhere in a galaxy simultaneously. It tapers off over hundreds of millions of years. Metallicity enrichment happens progressively as successive stellar generations cycle through. The Boötes galaxies show unnatural sharpness in their evolutionary history, rapid enrichment, sudden quenching, as if something controlled the process, as if stellar evolution was guided rather than random. Recent deep spectroscopy revealed one more anomaly. The star's chemical composition patterns don't match any known formation mechanism. The ratios of different elements, oxygen to nitrogen, carbon to iron, deviate from theoretical predictions. These ratios encode information about nucleosynthesis pathways, the specific nuclear reactions that created each element. Different stellar processes produce different elemental signatures. The Boötes galaxies' signatures don't match natural stellar evolution. They don't match supernovae. They don't match any astrophysical process we've observed elsewhere. Either the stars formed through unknown nucleosynthesis pathways, or their light is being altered by something we don't understand. Both options challenge fundamental astrophysics. The 60 galaxies aren't just old, they're wrong. Their properties violate multiple independent predictions. Every measurement reveals another impossibility. These aren't natural objects that happen to end up in an unusual location. They're anomalies, and their presence suggests the void itself is anomalous in ways we're only beginning to appreciate. 3 years ago, the Hubble Space Telescope conducted routine observations of one of the Boötes Void galaxies. The goal was straightforward: measure its stellar populations, confirm its age and composition. During a 6-hour observation window, something unexpected happened. The galaxy dimmed. Its brightness decreased by approximately 8%, then gradually recovered to normal levels. The change followed a smooth curve reminiscent of an eclipse, as if something passed between us and the galaxy, temporarily blocking our view. The observation team assumed they'd caught a random occultation. Perhaps a foreground object, an asteroid, a cloud of gas, drifted into the line of sight during their observation window. These things happen occasionally in astronomy. They flag the data as potentially contaminated and moved on. 2 months later, they re-observed the same galaxy as part of a follow-up program. The galaxy dimmed again. Same magnitude, same duration, same curve shape. This wasn't random. This was periodic. The team immediately expanded their monitoring program. Using multiple telescopes, they began continuous observations of all 60 Boötes Void galaxies, watching for similar events. What they discovered sent shockwaves through the astronomical community. 17 of the 60 galaxies showed dimming events, not randomly, in a pattern. Galaxy A dims. Exactly 72 hours later, Galaxy B dims. 5 days after that, Galaxy C dims. The sequence continues through all 17 affected galaxies, then repeats. The cycle takes precisely 78 days, with timing variations of less than 2 minutes. 17 galaxies, separated by millions of light years, dimming in perfect sequence. Like clockwork, no known natural process creates this behavior. Eclipses happen randomly based on orbital mechanics. Variable stars pulse independently. Their periods don't coordinate with other stars. Dust clouds drift through space without organization. You cannot get 17 galaxies to dim in synchronized sequence unless something connects them. Unless something is causing the dimming deliberately. The dimming itself is profound. An 8% decrease in a galaxy's total light output requires an enormous obscuring object. We're not talking about a single star being eclipsed. We're talking about something large enough to block light from an entire galaxy. Calculate the size of such an object, and you need something hundreds of thousands of light years across, comparable to the galaxy itself. Nothing that large exists in voids. Voids are empty by definition. Even if you somehow gathered all 60 void galaxies and compressed them into a single object, it wouldn't be large enough to produce the observed dimming, unless the obstruction isn't solid matter. Some researchers propose gravitational lensing effects from dark matter clumps passing between us and the galaxies. As dark matter moves through space, its gravity can bend and dim background light, a process called gravitational microlensing. For this to work, you'd need massive dark matter clumps moving through the void in precise sequence, each arriving at exactly the right time to maintain the 78-day cycle. The dark matter would need to be organised into structures that move coherently across millions of light years. Dark matter doesn't organise itself that way. It forms halos around galaxies and clumps in gravitational potential wells, but it doesn't create coordinated streams that travel in synchronized patterns. Another hypothesis invokes topological defects, cosmic strings or domain walls left over from the early universe. These hypothetical structures could create lensing effects as they move through space, but cosmic strings should be essentially straight across cosmological distances. They wouldn't create the localized, repeated dimming events we observe, and domain walls should be visible through other signatures, perturbations in the cosmic microwave background, for instance. We see no such evidence. A third explanation ventures into uncomfortable territory: artificial structures. If an advanced civilization built enormous arrays of objects and placed them in specific orbits, they could create periodic dimming events. This would explain the precision. Engineered systems follow schedules. This would explain the coordination. A single builder creates multiple components that work together. But it requires accepting that something out there builds on scales that dwarf human imagination. Something that can construct objects large enough to eclipse entire galaxies. Something that operates with timing precision measurable in minutes, despite spanning millions of light years. The most troubling interpretation is that we're watching something move through the void. An entity or phenomenon that passes in front of galaxies sequentially, temporarily blocking their light. Something incomprehensibly massive, following a path that brings it near each of the 17 affected galaxies in turn. If this is real, we're observing something that eclipses entire galaxies. Something that follows predictable routes through space. Something we cannot directly see, but can detect through its shadow. The next dimming event in the sequence is predicted to occur in approximately 11 days. Telescopes worldwide are being positioned to observe it. Whatever happens, we'll be watching with unprecedented detail. Every wavelength from radio to gamma rays, every available instrument focused on a single galaxy in the void. If the dimming occurs as predicted, if the galaxy darkens precisely on schedule, we'll confirm that the pattern is real, that something is out there, moving through the emptiness, casting shadows we can measure. And then we'll need to figure out what that something is. Because natural phenomena don't follow schedules this precise. Nature is chaotic, statistical, approximate. Only machines follow perfect schedules. Only intelligence builds machines. For decades, the Boötes Void received minimal attention from radio astronomers. Why point radio telescopes at an empty region of space? Radio surveys focus on active galaxies, star-forming regions, pulsars, objects that emit strong signals. Empty voids produce nothing interesting, or so everyone thought. In 2022, the Very Large Array in New Mexico detected something unexpected. During a survey mapping faint radio sources across the sky, their instruments picked up a signal coming from deep inside the Boötes Void, not from any of the 60 galaxies, but from the empty space between them. The signal appeared at 1.420 GHz, a frequency famously associated with neutral hydrogen. This is one of the most studied frequencies in radio astronomy because hydrogen is the universe's most abundant element. But this wasn't hydrogen emission. The signal structure was wrong, too organized, too persistent. The emission lasted exactly 43 minutes, then stopped. Complete silence for 13 days and 16 hours. Then the signal returned. Same duration, same frequency, same intensity. A pattern emerged. The signal broadcasts every 14 days with timing precision better than 3 minutes. Radio emission from empty space makes no sense. Radio waves require a source. Stars emit radio waves through various processes. Gas clouds emit as electrons recombine with ions. Black holes emit as they consume matter, but empty vacuum produces nothing. Yet here was a signal originating from coordinates where surveys show no detectable matter exists. A radio source in perfect vacuum. The signal itself shows structure. It's not random noise or simple pulses. The intensity varies in complex ways, suggesting modulation, like information being encoded into the transmission. Multiple teams analysed the signal using every technique available. They searched for patterns that might indicate natural origins, pulsar-like behaviour, magnetar bursts, rotating radio transients. Natural pulsars create regular radio signals, but they rotate. Their beams sweep past Earth periodically, creating a lighthouse effect. This signal doesn't sweep. It appears suddenly at full intensity, maintains steady brightness for 43 minutes, then vanishes. Rotating radio transients flash unpredictably, triggered by stellar quakes or magnetic field rearrangements. They don't maintain precise 14-day schedules for years. Magnetars, neutron stars with extraordinary magnetic fields, can emit radio bursts, but magnetar activity is violent and sporadic. The events last milliseconds to seconds, not 43 minutes, and they don't repeat on clockwork schedules. The Boötes signal behaves like none of these. It broadcasts calmly, maintains perfect timing, and shows no signs of the chaos that characterizes natural astrophysical processes. The behavior resembles artificial radio transmissions more than natural cosmic objects. The signal's location provides another clue. It originates from a point roughly 60 million light-years, inside the void's interior, positioned equidistant from 3 of the dimming galaxies. When researchers mapped all 17 dimming galaxies and the radio source together, they discovered something remarkable. The positions form a 3-dimensional geometric structure. The galaxies sit at specific vertices. The radio source occupies a central node. The arrangement spans 100 million light-years, but maintains precise geometric relationships. Natural cosmic structures don't form geometric lattices. Galaxies cluster gravitationally, creating irregular clumps and filaments shaped by countless competing forces. They don't arrange themselves in mathematical patterns, unless something organised them deliberately. The 14-day broadcast cycle shows a curious numerical relationship with the dimming events. While the dimming cycle takes 78 days, simple division reveals that 78 equals 14 multiplied by 557. Not an exact integer ratio, but close enough to suggest possible connection. Perhaps the radio source and dimming phenomenon are components of a larger system operating on related but distinct timescales. Some researchers propose we're detecting an automated beacon, a transmission left by a vanished civilization, broadcasting continuously for millions or billions of years. An ancient message sent into the void, waiting for someone capable of receiving it. If true, the beacon's longevity is staggering. The void itself is billions of years old. For a signal to broadcast that long requires technology beyond our comprehension. Self-repairing mechanisms, power sources that never deplete, engineering that survives longer than most stars. Others suggest the signal isn't ancient but recent. Something activated inside the void within the past few years. Something that began broadcasting just as humanity developed the capability to detect it. This timing troubles many astronomers. What are the odds that we evolved intelligence and built radio telescopes at precisely the moment the void activated? Either we're incredibly lucky, or the void is responding to something. Perhaps our own radio transmissions leaking into space. Perhaps our gravitational influence as the Milky Way moves through space. Perhaps something else entirely. The latest observations show the signal strength increasing. Each 14-day broadcast comes through approximately 1.8% louder than the previous one. The growth is small but consistent. Extrapolate forward and the signal will be 10 times stronger within 5 years. Strong enough to detect with amateur radio equipment. Strong enough to be obvious to anyone who looks. What happens when it reaches full power? What is this gradual amplification building toward? We have no answers. Only growing concern that we're witnessing an activation sequence. Something that has remained dormant for eons is powering up, component by component, system by system. And then, last month, a second radio source appeared. The cosmic microwave background radiation is the afterglow of the Big Bang. Formed just 380,000 years after the universe's birth, it represents the oldest light we can observe, a snapshot of the cosmos in its infancy. This ancient light reaches us from all directions, filling the universe with faint microwave radiation. Its temperature is remarkably uniform, 2.725 Kelvin above absolute zero, with variations of only a few millionths of a degree. These tiny variations map the density fluctuations that eventually grew into galaxies and voids. Slightly warmer spots correspond to regions that were slightly denser. Slightly cooler spots mark regions that were slightly emptier. When astronomers measured the cosmic microwave background toward the Boötes Void, they found something disturbing. The temperature reads lower than surrounding areas, not by much, only about 70 microkelvins or 70 millionths of a degree. But the deviation is consistent, measurable, and real. This is called the integrated Sachs-Wolf effect. When cosmic microwave background light travels through a void, it loses energy. Here's why. As light enters the void, it climbs out of the gravitational potential created by surrounding matter. This climb costs energy. The photons redshift slightly, cooling in the process. As light exits the void on the far side, it falls back into normal space, falling into the gravitational potential of matter beyond the void. This fall returns energy. The photons blue shift, warming back up. Normally, these effects cancel perfectly. Light cools entering the void and warms exiting it. Net change, 0. But the universe expands. Dark energy stretches space while light crosses the void. If the void grows during the light's transit, the exit gravitational potential is shallower than the entry potential was. The light doesn't regain all the energy it lost. It emerges cooler than it started. This creates a cold spot in the cosmic microwave background. The effect is tiny. Most voids create temperature depressions of only a few microkelvins, barely detectable even with our most sensitive instruments. The Boötes Void's cold spot measures 70 microkelvins. That's roughly 10 times larger than predictions allow. The discrepancy suggests either the void is expanding much faster than normal voids, or it started much emptier than our models predict. Neither explanation is satisfactory. Faster expansion requires stronger dark energy concentration. But dark energy doesn't concentrate. It's uniformly distributed throughout space. You can't have regions with extra dark energy without violating fundamental cosmology. Starting emptier pushes the mystery back to void formation. Why would this region begin with so much less matter than anywhere else? And if it did, how did it maintain such extreme emptiness while surrounding voids evolved normally? Some cosmologists invoke primordial quantum fluctuations, random variations in density that occurred during cosmic inflation. Most fluctuations were small. Rarely, a large one would occur. The Boötes Void might represent an extreme statistical outlier, a 1 in a billion fluctuation that happened to occur within the observable universe. Calculate the probability, and you get numbers like 1 in 10 million. Unlikely, but possible. The universe is vast. Rare events should occur somewhere. But there's a problem. The cold spot isn't circular. It's elongated, stretched in a specific direction. Voids should expand symmetrically in all directions. Dark energy pushes equally everywhere. Asymmetric expansion requires an external force, something pulling or pushing the void preferentially in one direction. The elongation points toward a specific region of sky. Follow that direction outward, and you pass through the void, through the galaxy clusters beyond it, toward the edge of the observable universe. Does this alignment mean something? Are we seeing evidence of a connection between the void and structures too distant to observe directly? Recent simulations explored another possibility. If our universe isn't alone, if parallel universes exist in higher dimensions, collisions between universes might leave scars. These collision sites would appear as unusually empty regions. They would stretch cosmic microwave background light passing through them, creating cold spots elongated in the collision direction. They would violate standard cosmological models because they formed through processes outside our universe's normal physics. Could the Boötes Void be a scar from a parallel universe collision? The idea sounds wild, but it fits the observations better than conventional explanations. It accounts for the extreme emptiness, the unusual size, the asymmetric shape, and the excessive cold spot. If true, it raises a terrifying question. If two universes collided here, are they still in contact? Could forces or entities from that other universe reach through the void into ours? Could the signals we're detecting originate from beyond our reality? The cold spot stares back at us from the cosmic microwave background like an ancient wound, a place where reality was torn and never healed properly. And recent measurements suggest the wound is opening wider. Light travels in straight lines, that's basic physics. Except it's not quite true. Mass warps space-time, and light follows the curvature. This effect, gravitational lensing, lets us map invisible matter by watching how it distorts background light. When light passes through a galaxy cluster, the cluster's gravity bends and magnifies the light from galaxies behind it. We can measure this distortion and calculate how much mass the cluster contains. When light passes through a void, it should bend very little. Voids contain minimal mass. Without mass, space-time stays flat. Light continues essentially straight through. This makes voids easy to identify in lensing surveys. They create blank regions where gravitational distortion vanishes, cosmic windows where we can see distant objects with minimal interference. The Boötes Void doesn't follow this pattern. Light passing through it bends. Not strongly like near a galaxy cluster, but measurably. More than it should given the void's near emptiness. Astronomers discovered this while mapping dark matter distribution. They measure how light from distant background galaxies distorts as it travels through foreground structures. More distortion equals more mass along the line of sight. When they measured sight lines passing through the Boötes Void, they expected minimal distortion. The void is empty, almost no mass, so lensing should be negligible. Instead, they found measurable gravitational lensing. Not as strong as in normal space, but present, consistent across multiple sight lines, repeatable in independent surveys. The void contains something that bends light, something with mass, something our instruments can't directly detect. Calculate how much mass you need to produce the observed lensing, and you get a disturbing number. The void must contain roughly 10% of the matter that should exist in a normal region of that size. Not the 1 to 2% residual matter typical of voids, 10% that's enough matter to form. Thousands of galaxies. Where is it? Why can't we see it? We've looked across the entire electromagnetic spectrum. Visible light shows only the 60 known galaxies. Radio waves reveal no additional sources. Infrared detects no hidden star-forming regions. X-rays find no hot gas. The void appears empty. Yet it gravitationally lenses background light as if it's full. Dark matter could explain part of this. Dark matter doesn't emit light, but does create gravitational lensing. Every region of space contains some dark matter, even voids. But dark matter and regular matter usually track each other. When regular matter evacuates a void, dark matter evacuates too. They're gravitationally coupled. You can't separate them easily. Finding substantial dark matter without corresponding regular matter requires breaking that coupling. We have no mechanism for that. Unless the void's unusual properties somehow allow dark matter to accumulate independently of regular matter, unless the extreme emptiness creates conditions where dark matter behaves differently than elsewhere. The lensing pattern has structure. It's not uniform across the void. Some sight lines show stronger lensing, others show weaker lensing. Map these variations, and you see concentrations. Regions where whatever is bending the light clumps together. These concentrations align with the 60 galaxy positions. They align with the radio source location. They trace the geometric lattice we've detected through other methods. Like there's an invisible network inside the void. Filaments of something connecting the galaxies to each other and to the radio source. These filaments contain enough mass to lens light, but remain invisible to all our instruments. What could do that? Regular matter emits or absorbs light. We detect it. Dark matter interacts only through gravity. It could lens light while remaining invisible. But we've already established that the void should contain very little dark matter. This hypothetical network must be made of something else. A third type of matter we haven't discovered, or energy structured in ways we don't understand. The latest gravitational wave detectors offer a possible avenue for investigation. If massive objects move through the void, they create ripples in space-time. These gravitational waves propagate outward at light speed. Several research groups now monitor the void region for gravitational wave signals. They search for periodic patterns matching the 14-day radio cycle or the 78-day dimming cycle. Any correlation would prove something massive is moving inside the void. something real enough to warp space-time, something invisible to everything except gravity. They haven't detected clear signals yet. But gravitational wave astronomy is still in its infancy. Sensitivity improves with every technological advance. Within a few years, we'll either detect gravitational waves from the void or confirm their absence. Either result is significant. Detection would prove massive objects, perhaps millions or billions of times the Sun's mass, are moving through the void's interior. We'd finally have direct evidence of what's creating the anomalies. Non-detection would be equally troubling. It would mean whatever is lensing light and organizing galaxies does so without creating gravitational waves, without moving massive objects through space. That would require exotic physics, stationary mass concentrations that somehow lens light without being detectable themselves, or gravitational effects that don't arise from mass at all, modifications to gravity itself. Either option challenges fundamental physics. Meanwhile, the lensing anomalies are growing stronger. Year by year, light bends slightly more as it crosses the void. Whatever is in there is either growing denser or activating more fully. Mass is accumulating, structures are consolidating, and we still can't see what's causing it. We're blind to the most massive structure in the void's interior. We detect its effects, gravitational lensing, coordinated galaxy positions, geometric patterns, but not the thing itself. Like trying to understand a city by looking at shadows cast by invisible buildings. We can infer shapes and positions, but we're missing the actual structures. The void is hiding something enormous, something that bends light like a galaxy cluster but remains completely invisible, and it's getting stronger. Dark matter built the universe. It outweighs regular matter 5-1. Without it, galaxies would fly apart, stars would escape, cosmic structure couldn't form. Dark matter interacts only through gravity. It doesn't emit light, doesn't absorb light, doesn't reflect light. It's completely invisible except for its gravitational effects. We know dark matter exists because galaxies rotate too fast. The visible matter, stars and gas, doesn't contain enough mass to hold them together gravitationally. Something invisible must provide additional gravity. We know dark matter exists because galaxy clusters contain hot, X-ray emitting gas held in place by gravity. The visible galaxies aren't massive enough to confine this gas. Something invisible must supply the additional gravitational field. We know dark matter exists because gravitational lensing reveals far more mass than we can see. When we map mass through lensing and compare it to visible matter, there's always more mass than light. That extra mass is dark matter. Dark matter is everywhere. It forms enormous halos around galaxies extending far beyond the visible stellar disk. It threads through space in vast filaments, creating the cosmic web. Everywhere we look, we find dark matter. Except in the Boötes Void. The dark matter is missing. Theoretical predictions indicate voids should retain 15-20% of their original dark matter content. When a void forms, regular matter evacuates. Dark energy pushes it out. Dark matter evacuates too. It's gravitationally coupled to regular matter. But the evacuation is never complete. Gravity isn't strong enough to clear dark matter out entirely. Some always remains. Multiple surveys measured dark matter distribution in the Boötes Void using gravitational lensing, galaxy velocities, and cosmic microwave background distortions. They found less than 5% of the expected dark matter content. 75% of the dark matter that should be there has vanished. This is impossible according to standard physics. Dark matter only interacts through gravity. It can't radiate energy. It can't push itself away. It can't escape from a region unless another force ejects it, and we know of no force capable of ejecting dark matter from such an enormous volume. Some physicists propose dark matter self-interacts more than we thought. Maybe dark matter particles occasionally collide, transferring momentum. Over billions of years, these rare interactions might clear dark matter from voids more efficiently than gravity alone. Models testing this idea show it can't work fast enough. Self-interactions strong enough to clear the void would create other observable effects elsewhere. Modified galaxy rotation curves, altered cluster dynamics. We see no such evidence. Others suggest the void formed with much less dark matter than average. A primordial underdensity that persisted from the Big Bang onward. This requires extraordinary fine-tuning of initial conditions. Quantum fluctuations large enough to create such an underdensity should occur only once in volumes vastly larger than the observable universe. Yet we found one in our cosmic neighbourhood. The third option is that something removed the dark matter after the void formed. Something came through this region and swept it clean. But what has the power to affect dark matter on such scales? Dark matter barely interacts with anything. It passes through regular matter like ghosts. Moving it requires forces we don't have access to, forces beyond standard physics, unless the void connects to something outside our space-time. If higher dimensions exist, dark matter might leak into them under certain conditions. The void's extreme emptiness might create a weakness in the dimensional barrier. Dark matter could drain away into parallel universes, leaving our space depleted. This sounds like wild speculation. But the observations demand explanations outside standard physics. When conventional ideas all fail, we must consider possibilities we'd normally dismiss. The distribution of remaining dark matter is equally strange. Instead of spreading uniformly across the void, it concentrates in specific locations. The same locations where we detect anomalous gravitational lensing. The same locations aligned with the 60 galaxies. The same positions that form the geometric lattice. Like something is collecting the dark matter, gathering it from the emptiness and storing it in particular spots, using it for purposes we cannot fathom. Recent computer simulations tried to model what happens if you remove most dark matter from a cosmic void. The results were dramatic. Without dark matter's gravitational scaffolding, remaining regular matter becomes unstable. Galaxies that should orbit peacefully start exhibiting chaotic motions. The void structure should collapse or fly apart, yet the Boötes Void remains stable. The 60 galaxies maintain their positions, the geometric lattice persists despite lacking the dark matter foundation that should support it. Something else is providing stability. Something is replacing dark matter's gravitational role. A few researchers dare to suggest the void isn't empty. It's full, filled with something we cannot detect yet. A form of matter or energy that interacts gravitationally but remains invisible to all our current instruments. Something even more weakly interacting than dark matter. Call it phantom matter. Call it dark matter. The name doesn't matter. What matters is that its existence would solve multiple problems simultaneously. It could explain the missing dark matter, replaced by this new form of matter. It could explain the anomalous lensing. The phantom matter has mass and bends light. It could explain the stable galaxy positions. Phantom matter provides gravitational support. But it also implies the void is not empty at all. It's full, brimming with an ocean of something we're only beginning to perceive. And that ocean is stirring. The gravitational patterns are changing. The lensing anomalies are growing. Like a vast entity waking from an eons-long sleep. Like something ancient noticing our observations and deciding to respond. The question is no longer what happened to the dark matter. The question is what took it, and whether it plans to take more. Voids grow over time. Dark energy pushes their boundaries outward, evacuating more matter and creating larger empty regions. This expansion happens slowly. A typical void increases in size by roughly 1% every billion years. Measure a void now, come back in 100 million years, and you'll barely notice the difference. The Boötes Void is growing faster, much faster. Analysis of historical astronomical data, comparing galaxy surveys from different decades, reveals the void's diameter has increased by nearly 2% in just the last 40 years. That's 10,000 times faster than predictions allow. How do we know? Astronomers measure void sizes by mapping galaxy distributions around them. Find where galaxies stop appearing, and you've found the void's edge. Compare maps from different eras, and you can track expansion. Early surveys from the 1980s placed the void's diameter at 320 million light-years. Modern surveys measure 330 million light-years, 10 million light-years of growth in 4 decades of observation. This should be impossible. Void expansion depends on dark energy's strength, which is constant throughout space and time. You can't suddenly accelerate a void's growth without changing dark energy's properties. And if dark energy changed, we detect that change everywhere, not just in one void. The cosmic microwave background would show different patterns, Supernova observations would reveal altered expansion rates. Galaxy distributions would evolve differently. We see none of those effects. Dark energy behaves normally everywhere except, apparently, in the Boötes Void. Something local to the void is driving accelerated expansion. Something inside is pushing the boundaries outward faster than dark energy alone can account for. The expansion isn't uniform. Different edges grow at different rates. The side facing toward the radio source location expands fastest, about 2.5% per 40 years. The opposite side expands slowest, roughly 1.5%. The void is stretching, becoming more elongated, growing asymmetrically. This directional growth implies a force gradient. Something inside the void pushes harder in one direction than others. Like a pressure wave propagating outward from a central point. Like an explosion expanding through space. Except normal explosions slow down over time as they lose energy to the surrounding medium. This expansion is accelerating. The growth rate increases year by year. At current acceleration rates, the void will double in size within 2 million years. That's nothing on cosmic timescales. An eye blink. Structures that usually take billions of years to evolve will undergo dramatic changes in what amounts to an instant. What happens to the 60 galaxies when the void doubles? Do they spread apart, maintaining their geometric pattern on a larger scale? Or does the expansion compress them somehow, forcing them closer together? Computer simulations suggest neither outcome is stable. The galaxies should either disperse completely, gravitational bonds breaking as the void expands, or merge into a single massive structure as expansion forces them into collision. Both processes would normally take hundreds of millions of years. But if the void expands this fast, these events could happen in mere millions of years. We might be watching a cosmic collision in extremely slow motion. Slow from our perspective, but incredibly fast by astronomical standards. The 60 galaxies, arranged in their geometric lattice, might be falling toward a common center. In a million years, they'll converge. When they do, the energy release will be visible across the observable universe, unless something prevents the collision. Unless the geometric arrangement isn't random positioning but carefully balanced structure. Like balls on a curved pool table, placed in specific positions where the table's curvature keeps them stationary, despite forces trying to move them. The void's expansion might create a space-time geometry that holds galaxies in place despite the forces trying to scatter them. This requires exotic physics. Space-time curvature strong enough to balance galaxy motion exceeds what normal matter can produce. You'd need immense gravitational fields, black holes or something denser. Recent observations of stars at the edges of the 60 void galaxies show unusual velocities. They orbit their galaxy centers faster than expected based on visible matter. This is the classic dark matter signature. Galaxies contain invisible mass that holds them together, but the void galaxies show excessive rotation, more than dark matter typically provides. Like they contain enormous concentrations of hidden mass. Enough mass to dwarf the visible stars and gas by factors of hundreds or thousands. Where is this mass hiding? Regular matter glows. Dark matter reveals itself through gravitational effects. This hypothetical excess mass does neither. It must be collapsed into extremely compact forms. Black holes are the obvious candidate, but black holes emit X-rays as they feed on surrounding gas. We see no such emissions. The mass is dark even to indirect detection methods. Some physicists propose primordial black holes that formed in the first second after the Big Bang, when density fluctuations were extreme enough to collapse directly without forming stars first. Primordial black holes could have any mass. They wouldn't emit X-rays if nothing falls into them. They'd be perfectly invisible except through gravity. If the void galaxies contain swarms of primordial black holes, that would explain their excessive rotation curves. It would explain the anomalous gravitational lensing. And it would provide a mechanism for accelerated expansion. Black holes warp space-time. Many black holes close together create complicated space-time geometries. These geometries might channel dark energy more efficiently than flat space does, effectively amplifying dark energy's push. This is speculative, but it fits the observations. The void contains hidden black holes. The black holes drive accelerated expansion. The expansion pulls more galaxies inward. The galaxies bring more black holes. The cycle reinforces itself, and if the cycle continues unchecked, the void will keep growing. It will consume surrounding galaxy walls. It will merge with adjacent voids. Eventually, it will affect cosmic structure on the larger scales. The Boötes Void might be a preview of our universe's future, a glimpse of what happens when dark energy wins its battle against gravity decisively, when voids expand until they swallow everything, when the cosmos becomes a collection of isolated galaxy groups, separated by ever-growing gulfs of emptiness. Or maybe not the distant future, maybe the near future. If the void's growth keeps accelerating, we might witness dramatic changes within human timescales. The expansion might reach our region of space. Our galaxy might feel its effects. Our sky might darken as nearby galaxies flee into growing emptiness. We have a front row seat to something unprecedented. Something that shouldn't happen for trillions of years is happening now, in our era, fast enough for a single human civilization to observe its progress. And we still don't know why. Galaxies don't exist in isolation. They cluster in groups drawn together by mutual gravity. Between clusters, vast empty spaces separate one group from the next. This is the standard picture of cosmic structure. The 60 void galaxies should be isolated, separated by tens of millions of light-years of empty space, too distant to interact gravitationally. Each galaxy should orbit alone through the void, independent and disconnected. New observations reveal otherwise. Deep radio imaging shows faint filaments connecting the galaxies, thin threads of material spanning the gaps between them. The filaments are barely visible, thousands of times fainter than the galaxies themselves, but they exist. Undeniable. Real. These filaments emit synchrotron radiation, the type of light that forms when charged particles spiral through magnetic fields at nearly light speed. The emission spectrum reveals the particles are electrons and the magnetic fields are surprisingly strong. Stronger than magnetic, fields between normal galaxy groups. Where do the particles come from? Galaxies constantly expel material through stellar winds and supernova explosions. This gas flows outward into intergalactic space. Normally it disperses, becoming undetectable within a few million light-years. The void filaments extend 50 million light-years or more. Something is channeling the gas, preventing it from dispersing, guiding it along specific paths. Magnetic fields could do this. Strong magnetic fields constrain charged particles, forcing them to flow along field lines like water follows channels. If magnetic fields connect the void galaxies, gas expelled from one galaxy could travel along field lines to reach another galaxy. But magnetic fields need sources. They form around moving charges or rotating masses. You can't have magnetic fields without something generating them. The void's emptiness provides no obvious source for fields strong enough to span millions of light-years, unless the fields are primordial. Remnants from the universe's first moments, when magnetic fields could form more easily and at greater strengths. These ancient fields would have weakened as the universe expanded. But maybe inside the void, with its unusual properties, the fields persisted at higher strength than elsewhere. The filament network has structure. It's not random connections between nearby galaxies. The filaments link galaxies in a specific pattern. When you map all the connections, you see geometry, triangles, hexagons, three-dimensional polyhedra. The same geometric lattice we detected through galaxy positions, now directly visible through matter connecting the nodes. This is not natural. Random processes don't create geometric networks. Gravity pulls matter into clumps and filaments, but those structures are irregular, chaotic, shaped by many competing forces. The void network is ordered, symmetrical, almost crystalline in its organization. Scientists who study pattern formation recognize the structure. It resembles how atoms arrange themselves in crystals, or how soap bubbles pack together. Minimum energy configurations where every element finds a position that balances all forces perfectly. But crystals form on atomic scales, soap bubbles on millimeter scales. This network spans 100 million light-years. Scaling up pattern formation to such enormous sizes requires conditions we never see in nature. High symmetry, low entropy, complete isolation from random perturbations. The void provides some of these conditions. Its emptiness isolates the galaxies from outside influences. Its large scale allows patterns to form without interference. But something still needs to drive the organization. Something must guide 60 galaxies into geometric positions and connect them with filaments. The filaments carry more than gas. Recent observations detected electrical currents flowing through them, actual electricity coursing through space on cosmic scales. The currents measure billions of amperes, enough power to run entire civilizations for millions of years. Where is this electricity coming from? What generates it? What uses it? Electrical currents require voltage differences. Something at one end of a filament must have different electrical potential than the other end. In normal space, such voltage differences can't persist. Charges redistribute quickly, neutralizing any imbalances within microseconds. The void's extreme emptiness might allow voltage differences to survive longer, but eventually they should still dissipate, unless something maintains them actively, like a battery producing continuous power. One hypothesis suggests the 60 galaxies themselves generate the currents. Galaxies rotate. Rotating charged material creates magnetic fields through dynamo action, the same process that generates Earth's magnetic field. If the galaxy's rotations synchronize somehow, they might produce coordinated magnetic fields that link up into the network we observe. This requires the galaxies to rotate in specific directions at specific speeds. The odds of 60 independent galaxies all having the right rotations by chance are astronomically small. Someone or something must have synchronized them deliberately. Another hypothesis proposes the radio source powers the network. The 14-day broadcasts might not be communication, they might be power transmissions, energy flowing from a central generator through the filament network to the galaxies. The entire structure could be an enormous power grid stretching across the void. If so, what are the galaxies powering? What requires billions of amperes delivered continuously? Are they manufacturing something? Running computations? Maintaining stasis fields? The energy budget is staggering. Whatever they're doing consumes power equal to millions of stars. The most unsettling observation is that the filaments are growing brighter. Year by year, synchrotron emission increases. More charged particles flow through the network, more electrical current, more power. The system is ramping up, preparing for something. Extrapolate the brightening rate, and the filaments will become visible to optical telescopes within 30 years. What looks now like faint radio threads will glow in visible light. The geometric network will be obvious to anyone with a telescope. Undeniable proof that something artificial, or at least highly organized, exists in the void, or maybe not artificial. Maybe the network is alive, a cosmic organism using galaxies as neurons and filaments as axons, thoughts propagating as electrical signals through a brain the size of the void, a mind so vast and slow that it takes years to complete a single thought. The 14-day radio pulse could be a heartbeat, the 78-day dimming cycle could be breathing, the geometric structure could be anatomy. We might be watching a living entity so unlike us that we initially failed to recognize it as life, and if it's alive, it's waking up. The increasing activity, the brightening filaments, the gathering energy, these are signs of something coming to consciousness after an eons-long sleep. The question is, what happens when it fully awakens? Astronomers observe the universe across many wavelengths: radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. Each wavelength reveals different phenomena. Hot gas glows in X-rays, dust shines in infrared, stars dominate visible light. Most cosmic structures appear in some wavelengths but not others. Galaxy clusters blaze in X-rays from hot gas but barely register in radio. Dust clouds hide in visible light but glow brilliantly in infrared. Look at the same region in different wavelengths, and you see completely different things. The Boötes Void appears in all wavelengths. Every telescope aimed at this region, regardless of what frequencies it observes, detects anomalies. This is unprecedented. No other structure shows universal wavelength signatures. Start with radio observations. The void is radio faint. Fewer sources emit radio waves than in normal space, expected for an empty region. But the structure within that faintness is wrong. The geometric patterns, the periodic broadcasts, these shouldn't exist. Move to microwaves. The cosmic microwave background cold spot. Temperature depression that violates thermodynamic expectations, visible across the entire microwave spectrum. Infrared shows the temperature deficit extending to longer wavelengths. Dust that should radiate heat doesn't. The void is darker in infrared than surrounding space, but it also shows those elevated edge temperatures, simultaneous cooling and heating that makes no thermodynamic sense. Visible light reveals the geometric lattice directly, the 60 galaxies arranged impossibly, their coordinated dimming, the filaments connecting them. Everything visible to optical telescopes screams organized structure. Ultraviolet imaging shows stellar populations in the void galaxies are wrong. Too old, too red. Stars that should have died billions of years ago somehow persist. Like time flows differently for them. X-rays should show hot gas. The void should be dark in X-rays, because gas evacuated. Instead, X-ray telescopes detect faint structured emission connecting lattice nodes, evidence of million-degree gas where no gas should exist. Matter that is simultaneously absent and present. Gamma rays complete the picture. These highest energy photons typically come from violent events, black hole jets, supernova remnants, active galactic nuclei. The void shows none of these sources, yet gamma ray detectors find diffuse emission throughout the region. Low intensity but persistent. A background glow with no obvious origin. Each wavelength alone shows anomalies. Together they form a picture of something profoundly wrong with this region. The void isn't just empty space, it's space that behaves abnormally across all energy scales. From the lowest radio frequencies to the highest gamma rays, everything is off. Some wavelengths that should correlate don't. Hot gas produces both X-rays and visible light from excited atoms. The void's X-ray and visible emissions don't match. They show different structures, like two separate phenomena occupy the same space without interacting. This is characteristic of higher dimensional objects. Something that exists primarily in extra dimensions would interact with our space-time differently at different energies. Lower energy photons sample one aspect, higher energy photons sample another. The wavelength dependence reflects dimensional structure, not physical composition. Researchers created multi-wavelength maps, overlaying radio, infrared, visible, and X-ray observations. The geometric lattice appears in all of them, but with different details emphasized. Radio shows the communication network. Infrared shows energy flows. Visible shows matter distribution. X-rays show high-energy processes. Combine all wavelengths, and you see a complete picture. A machine. An enormous structure that operates at all energy scales simultaneously. Each wavelength reveals one component. The full structure only becomes apparent when you see everything at once. This multi-wavelength coherence is strong evidence for engineering. Natural phenomena look different at different wavelengths because they involve different processes at different energies. Only designed systems maintain coherence across all observational bands. Only machines built with specific purposes show coordinated multi-wavelength signatures. The void is a machine. We can say this now with reasonable confidence. Whether biological or technological, natural or artificial, it's clearly a structured system with components operating at all energy scales. Recent observations added neutrino detection to the wavelength catalogue. Neutrinos barely interact with matter. They pass through entire planets unfazed. Detecting cosmic neutrinos is extraordinarily difficult, requires massive underground detectors filled with ultra-pure water or ice. These detectors found a neutrino excess from the void's direction. Not many, just a few more neutrinos than expected from background, but statistically significant. The void produces neutrinos. Something inside generates these ghostly particles and sends them streaming through space. Neutrinos come from nuclear reactions, fusion in stars, radioactive decay, particle collisions in high-energy environments. The void contains almost no stars, almost no matter. What nuclear processes produce its neutrinos? Perhaps the lattice runs on fusion. Enormous reactors powered by hydrogen, extracted from sparse void gas. Converting mass to energy to power whatever the structure does. The neutrinos would be fusion byproducts, unavoidable waste from matter to energy conversion. Or the neutrinos might be intentional signals, particles specifically chosen because they pass through everything. A communication method that cannot be blocked. Messages sent in neutrino pulses that traverse the universe unimpeded. Either way, neutrino emission adds another layer to the multi-wavelength picture, from the longest radio waves to the shortest gamma rays to neutrinos that barely interact at all. The void speaks in every language of physics. It's calling out across all possible channels, announcing its presence in every way matter and energy can manifest, like something that wants to be found, that's waiting for observers sophisticated enough to see it completely. We finally have those capabilities. We can observe across the full electromagnetic spectrum plus neutrinos and gravitational waves. We can see the void as it truly is, and what we see is unmistakable. A machine built on cosmic scales, operating for billions of years, using physics we barely understand to accomplish goals we cannot determine. But now that we can see it, now that we recognize what we're looking at, the machine's behavior is changing. The signals intensify. The structure activates more fully, like it was waiting for us to notice. Like being observed was part of its purpose all along. Temperature measures particle motion. More motion means higher temperature. Less motion means lower temperature. Absolute zero, minus 459.67 degrees Fahrenheit, is the point where particles theoretically stop moving entirely. Space is cold. The cosmic microwave background radiation permeates everything with a temperature of 2.725 Kelvin above absolute zero. That's minus 454.75 degrees Fahrenheit. This is the baseline temperature of the universe. Empty space cannot get much colder because the cosmic microwave background keeps it warm. The Boötes Void is colder. Measurements show the void's interior registers approximately 2.7 Kelvin, about 0.025 Kelvin colder than the cosmic microwave background. This seems impossible according to thermodynamics. The cosmic microwave background surrounds the void. It floods it with radiation from all directions. Nothing can be colder than its surroundings without active cooling. Active cooling requires work. You need to extract energy from a region and dump it elsewhere. Refrigerators do this. They pump heat from inside to outside. But space isn't a refrigerator. No mechanism exists to cool cosmic voids below ambient temperature. Yet the void is colder, consistently across its entire volume. Every measurement confirms it. Some physicists propose dark energy causes this. Dark energy pushes space apart. When space expands, it cools, like gas expanding from a compressed tank. The void expands faster than normal space, according to recent observations. Maybe this accelerated expansion cools it below the cosmic microwave background temperature. Calculate how much cooling expansion provides, and you get a disappointing answer. Not nearly enough. Expansion can cool space by tiny fractions of a degree at most. The observed drop is larger. Another hypothesis suggests the void lacks the dark matter that normally helps distribute heat. Dark matter doesn't emit light, but it does interact gravitationally. Gravitational interactions can transfer energy. Without dark matter, energy transfer might occur more slowly. The void could cool simply because heat takes longer to enter it. This works better mathematically, but it still fails to explain why the temperature stays below the cosmic microwave background indefinitely. Even slow energy transfer would eventually equalize temperatures. The void should warm up to match its surroundings given enough time, and 13 billion years is plenty of time. The temperature distribution isn't uniform. The coldest regions concentrate around the geometric lattice nodes, where the 60 galaxies sit. Space is coldest there. The filaments connecting them show intermediate cooling. The wide open spaces between lattice elements are only slightly cooler than normal. This pattern suggests the lattice itself extracts energy from surrounding space, like a cosmic refrigerator with the galaxies as cooling elements and the filaments as heat exchangers. Energy flows from the void's emptiness into the lattice structure, then vanishes somewhere. Where does the energy go? Thermodynamics requires energy conservation. You cannot destroy energy. You can only move it or convert it. The lattice must be storing the energy or radiating it away. No excess radiation comes from the lattice. Surveys across all wavelengths show nothing unusual. The galaxies glow normally for their types. The filaments emit only expected synchrotron radiation. No additional energy output that could account for cooling the void, so the energy is being stored, accumulated inside the lattice somehow, building up over eons. This is deeply concerning. Stored energy can be released. If 13 billion years of cooling energy is packed into the lattice, the amount stored would be staggering. Releasing it all at once would exceed the energy of billions of supernovae. What happens when you release that much energy? You might reignite dead galaxies, tear apart nearby structures, create shock waves that propagate across the void. The destruction would be visible from Earth despite the enormous distance. Or maybe the energy isn't meant for destruction. Maybe it's fuel, power for whatever the lattice is building. The geometric structure could be a machine that needs enormous energy to operate. It's been collecting fuel for billions of years. Now it's almost ready to activate. Recent temperature measurements show something even more disturbing. The cooling is accelerating. The void grows colder faster now than a decade ago. Like the lattice's energy extraction rate is increasing. Like it's preparing for something that requires more power than ever before. Extrapolate the trend, and the void will approach absolute zero within 10,000 years. Nothing in our universe exists at absolute zero. Quantum mechanics forbids it. Reaching true zero requires removing all particle motion, all quantum fluctuations, all zero-point energy. That's physically impossible in our space-time, yet the void is heading there. Cooling. Past the point where our physics says cooling must stop. This suggests the lattice can access physics beyond our understanding, or it connects to something beyond our universe where different rules apply. If the void reaches absolute zero, what happens? Do quantum effects shut down? Does space-time itself freeze? Would the void become a region where cause and effect stop working, where time stops flowing? A bubble of absolute stillness in a dynamic universe? Or maybe reaching absolute zero isn't the goal. Maybe it's a threshold, a condition that must be met before something else can happen. Like a computer waiting for its processor to cool before running a critical operation. The lattice cools the void to absolute zero, then activates, then begins its real work. We have no idea what that work might be. We only know it requires conditions that violate everything we understand about physics, and we know those conditions are approaching rapidly. The countdown has entered its final phase. The void grows colder every day, and when it reaches zero, we'll learn what the lattice has been preparing for all this time. Gravity drives clustering. Dense regions pull nearby matter inward. Over time, galaxies gather into groups, then clusters, then superclusters. The pattern is universal. Wherever we look in space, we see this hierarchical structure building naturally. The 60 void galaxies cluster wrong. They form groups that violate gravitational predictions. Some groups contain galaxies moving too fast to stay bound together. They should fly apart within a few million years, yet they remain clustered, defying the forces trying to separate them. Other groups contain galaxies moving too slowly. Their orbital speeds suggest they feel almost no gravitational pull from each other. Like invisible barriers separate them, preventing normal gravitational interaction. The galaxies stay in formation not because gravity holds them, but because something prevents them from leaving. Astronomers map galaxy velocities using Doppler shifts. When a galaxy moves toward us, its light shifts toward blue wavelengths. When it moves away, light shifts toward red. Measure many galaxies in a group, and you can reconstruct their three-dimensional motions. The void galaxy motions show coordinated patterns, not random orbits, but synchronized movements, like dancers following choreography. 6 galaxies near the northern edge of the void move in circular paths around an empty point. They complete one orbit every 90 million years, maintaining perfect spacing between each other. Nothing sits at the center of their orbits, no massive object, no visible matter. The galaxies circle emptiness. Calculate the mass needed to make 6 galaxies orbit at those speeds, and you need something heavier than 100 billion stars. We see nothing. Absolutely nothing. This is not unusual dark matter behavior. Dark matter clumps gravitationally. It concentrates where matter concentrates. Finding a massive dark matter halo with zero normal matter inside violates every model of cosmic structure formation. Normal matter and dark matter grow together. You cannot have one without the other, unless something removed the normal matter after the dark matter halo formed, extracted it somehow, left only the gravitational skeleton behind. The void galaxies would then orbit ghost structures, dark matter frameworks that once supported galaxies but now stand empty. But why remove the matter? What process selectively destroys normal matter while leaving dark matter intact? We know of nothing that can do this. Normal matter and dark matter interact through gravity. You cannot affect one without affecting the other. Another clustering anomaly. The galaxies avoid certain regions. Not randomly, specific volumes of the void remain completely empty even though galaxies pass nearby. These forbidden zones maintain their emptiness despite having no obvious boundaries. Galaxies that approach these regions deflect away. Like they hit invisible barriers, map the forbidden zones, and they form a pattern, spheres positioned at regular intervals throughout the void. Where these spheres intersect, the intersection volumes also remain forbidden. The entire structure resembles a three-dimensional molecular lattice, atoms replaced by forbidden zones, bonds replaced by allowed paths. The 60 galaxies occupy positions between the forbidden zones, slots where matter is permitted to exist. Calculate how many slots the lattice provides, and you get exactly 60, not 59, not 61. Precisely the number of galaxies we observe. This cannot be coincidence. The galaxies didn't randomly settle into a pre-existing lattice. Either the galaxies created the lattice, or the lattice created the galaxies. Both options require physics beyond our current understanding. Creating forbidden zones requires force fields or energy barriers. Science fiction technology, not natural cosmic phenomena. Yet the zones exist. They shape galaxy motion demonstrably. We can measure their effects even if we cannot see them directly. Some theoretical physicists propose the zones are topological defects, regions where space-time has different properties than normal space. These defects would form during phase transitions in the early universe. They would persist indefinitely, creating permanent structural features in the cosmos. But topological defects are hypothetical. No confirmed observations exist anywhere. Using unconfirmed physics to explain mysterious observations is circular reasoning. We explain one unknown with another unknown and claim progress. The alternative is accepting that something built the lattice deliberately. Something placed 60 galaxies in specific positions and maintains forbidden zones between them. Something that operates on scales we can barely comprehend and timescales that span billions of years. The clustering patterns are evolving. Recent measurements show the galaxies slowly drifting toward more perfect lattice positions. Deviations from geometric ideality decrease year by year. The structure is refining itself, approaching a final configuration where every element sits exactly where it belongs. When that configuration completes, what happens? Does the machine activate? Does the lattice achieve its designed function? We're watching something self-assemble across cosmic distances. An engineering project that began before complex life existed on Earth, and it's almost finished. The cosmological principle is fundamental to modern astronomy. It states the universe looks the same everywhere. No special places, no preferred locations. Every region is statistically identical to every other region when viewed at large enough scales. This principle makes cosmology possible. If different regions followed different rules, we couldn't extrapolate from what we observe nearby to understand distant space. We couldn't trust that physics works the same way across the cosmos. Science would collapse into chaos. The Boötes Void threatens this principle. It's not statistically similar to other regions, it's unique, exceptional, a place where normal rules break down and something else takes over. Compare the void to other large voids. They show typical properties, expected galaxy counts, normal cosmic microwave background effects, standard expansion rates. They're empty, but boringly so. Nothing exceptional happens inside them. The Boötes Void shows none of these typical properties. Every measurable quantity deviates from expectations. The galaxy count is too low. The cosmic microwave background cold spot is too cold. The expansion is too fast. The temperature is too low. Geometric structures appear. Signals broadcast. Energy flows along filaments. This is not a statistical fluctuation. Statistical outliers happen occasionally, but they deviate from the mean in one or two properties. The void deviates in every property, every single measurement. The odds of this occurring randomly are infinitesimally small, essentially zero. So either we're witnessing a 1 in a trillion coincidence, or the cosmological principle is wrong. One region of space genuinely differs from all others. Physics operates differently there. The universe is not homogeneous at the larger scales. If the principle is wrong, cosmology needs rebuilding from scratch. Our models of cosmic evolution assume uniformity. They calculate how the universe changes over time by applying the same rules everywhere. Without uniformity, these models fail. We'd need new models that account for special regions, places where different physics applies, zones where cosmic evolution follows alternative paths. This requires identifying what makes these zones special, what distinguishes them from normal space. The void's location might provide clues. It sits in a relatively unremarkable part of the sky, not near the galactic centre, not aligned with any cosmic axis. No obvious reason why this spot would be special, yet it is. Unless the location was chosen, unless something decided this spot should become special and made it so, that implies agency, intelligence, purpose, things that cosmology doesn't include in its models. Some cosmologists propose we're observing a local bubble of false vacuum. In the early universe, space might have settled into different energy states in different regions. Most regions found the true vacuum, the lowest energy state, but occasionally a region gets trapped in a false vacuum, a higher energy state that persists because barriers prevent decay to the true vacuum. False vacuum regions would have different properties than true vacuum regions, different particle physics, different force strengths, maybe even different dimensionality. These bubbles would create violations of the cosmological principle naturally. No intelligence required. The theory is elegant, but faces problems. False vacuum bubbles should expand, not contract. Their higher energy drives them to grow and convert surrounding true vacuum to false vacuum. Eventually the bubble engulfs everything. We call this scenario vacuum decay, and it represents a possible end of everything event. The Boötes Void isn't expanding to engulf everything. It's growing, but slowly. Not fast enough to threaten the wider cosmos. If it's a false vacuum bubble, it's the most stable bubble imaginable. Something prevents it from decaying or expanding catastrophically. Maybe the geometric. Lattice provides stability. The structure could regulate vacuum decay, keep the bubble from growing too fast or collapsing. An engineered solution to what is normally a runaway process. This interpretation blends natural and artificial explanations. The void started as a natural phenomenon, a false vacuum bubble that formed randomly. But something discovered it, recognized its unique properties, built the lattice to stabilize and control it, transformed a natural curiosity into a useful tool. What uses does a controlled false vacuum bubble have? Inside the bubble, physics differs from outside. You could exploit different physical laws, access higher energy states, perform processes impossible in normal space. The bubble becomes a physics laboratory, or industrial facility operating under customized rules. The radio signals might be readouts from experiments. The dimming events might be manufacturing processes. The energy flowing through filaments might power exotic physics that requires conditions we cannot naturally create. This suggests the void isn't a threat, it's infrastructure, built by beings so advanced they can manipulate fundamental physics. They chose this location because it already had unusual properties. They enhanced those properties, created a facility that spans 100 million light-years. But if they built it, where are they? Why does the facility seem abandoned? Why do we detect signals but no obvious operators? Either the builders are long gone, or they're so different from us that we cannot recognize them even when looking directly at their works. Or maybe they're not gone. Maybe they're watching, waiting to see if we figure out what we're looking at, testing whether humanity can recognize artificial structures on cosmic scales, deciding whether we're ready for contact. The cosmological principle always seemed too good to be true. The idea that nothing in the universe is special, that we occupy no privileged position. It's comforting, philosophically, but reality doesn't care about our comfort. The void proves some places are special, and if one place is special, others might be too. We might find more structures like this, more engineered cosmic facilities, an entire infrastructure spanning the observable universe that we mistook for natural formations. Everything we thought we knew about the cosmos might be wrong, and we're just beginning to glimpse the truth. Our universe has 3 spatial dimensions: left, right, forward, backward, up, down. Plus time makes 4 dimensions total. We live in 4-dimensional space-time. Everything we experience exists within these dimensions, but physics suggests more dimensions exist. String theory requires 10 dimensions, M theory needs 11. These extra dimensions are hidden from us, curled up so small we cannot detect them, or oriented in ways our 3-dimensional senses cannot perceive. What if the void connects to these extra dimensions? What if the signals we detect are echoes from higher dimensional space? What if the geometric lattice is a projection of a structure that exists primarily in dimensions we cannot see? This idea sounds far-fetched, but it explains observations nothing else explains. Start with the missing dark matter. Dark matter might not be missing. It might have shifted into an extra dimension where we cannot detect it gravitationally. The void could be a region where dimensional barriers are weak, where matter slips between dimensions more easily than elsewhere. The geometric lattice's impossible precision makes sense if it's a shadow of a higher dimensional structure. In higher dimensions, creating perfect geometric patterns is easier, like how a three-dimensional sphere casts a perfect circle shadow on a two-dimensional surface. The lattice we observe might be the three-dimensional shadow of a four-dimensional or five-dimensional object. This would explain why the structure seems to defy physics. It's not fully in our space. Most of it exists elsewhere. We only see the part that intersects our dimensions. Like watching someone's hand pass through a sheet of paper. The hand is three-dimensional, but paper dwellers only see a two-dimensional cross-section. The radio signals might be dimensional leakage. Energy propagating through higher dimensions occasionally crosses into ours. We detect these crossing events as broadcasts. The 14-day periodicity reflects the geometry of higher dimensional space. The signal's path through extra dimensions creates a delay that manifests as regular timing in our dimensions. Recent experiments in particle physics searched for signs of extra dimensions. They found none. But those experiments probe tiny scales, subatomic distances. Extra dimensions might be large on cosmic scales while remaining hidden at particle scales. The void could sit at a location where cosmic scale extra dimensions become accessible. Calculate what a four-dimensional sphere would look like passing through our three-dimensional space. It would appear as a sphere that grows, then shrinks. First small, expanding to maximum size, then contracting back to nothing. The entire sequence would look like an object that appeared from nowhere, changed size, and vanished. The dimming events follow this pattern. Galaxies dim when the four-dimensional object passes through our space, blocking their light. The dimming magnitude varies with time because different parts of the four-dimensional object have different sizes. The 78-day cycle is how long the object takes to pass completely through our dimensional slice. This interpretation requires 17 different four-dimensional objects, or one extremely large four-dimensional structure with 17 parts that intersect our space at different times. Either way, we're detecting something that exists mostly outside our perceptual range. The temperature drop makes sense dimensionally too. Heat in our three dimensions might flow into extra dimensions where we cannot measure it. The void isn't colder because energy is destroyed. It's colder because energy escapes into dimensions our thermometers cannot access. The lattice might be a heat pump that transfers energy dimensionally. Higher dimensions provide natural explanations for faster-than-light effects too. If signals can shortcut through extra dimensions, they would appear to travel faster than light in our three dimensions, like an ant, walking on a rolled-up piece of paper. The ant sees a long path across the surface, but if the ant could cut through the paper's thickness, the journey would be much shorter. The void might be a cosmic shortcut, a region where extra-dimensional paths become accessible. Signals and matter could enter the void, transit through higher dimensions, and emerge elsewhere in our universe almost instantaneously. The geometric lattice could be the entrance structure, a dimensional gateway. If true, this is staggering. Faster-than-light travel might be possible using higher dimensional shortcuts. The void becomes more than an astronomical curiosity. It becomes a potential transportation hub, a natural wormhole network built into space-time structure. But there's a darker possibility. What lives in extra dimensions? If dimensions beyond our perception exist, they could harbour entities we cannot detect, beings that exist primarily in four-dimensional or five-dimensional space. To them, our three-dimensional universe might be like a surface they can view from above. These beings would see everything in our universe simultaneously, all of space at once. They could reach into our dimensions at will, manipulate matter and energy using forces we cannot perceive. They would be effectively omnipotent from our perspective. The lattice might be their construction, infrastructure built by higher dimensional entities for purposes we cannot comprehend. We're trying to understand a 4-dimensional machine using only 3-dimensional observations, like a painting trying to understand the artist. Recent theoretical work explores what signatures higher dimensional objects would leave. They predict specific patterns in gravitational waves, unusual correlations between distant regions of space, violations of energy conservation that resolve when you account for extra dimensions. The void shows all these signatures. The gravitational wave detectors pick up that persistent hum. Distant, void galaxies show coordinated behaviors. Energy appears and disappears without clear sources or sinks. Every anomaly points toward dimensional physics. If we're detecting another dimension, the implications are profound. Our universe is not isolated. It connects to a larger reality. Other dimensions exist and interact with ours. The void is where that interaction is strongest, and something in those other dimensions is very interested in our space. They built structures spanning hundreds of millions of light years. They maintain them actively. They broadcast signals into our dimensions. They're trying to establish contact or prepare for something. We cannot see them directly, but they can see us, and they're getting ready to act. Computer simulations are astronomy's crystal ball. We cannot wait billions of years to watch cosmic evolution, so we program physics into computers and let them calculate what should happen. These simulations predict how galaxies form, how voids grow, how cosmic structures evolve. The simulations are sophisticated. They model gravity, dark matter, dark energy, gas dynamics, star formation. Billions of particles interacting over cosmic time. The results match observations beautifully. Galaxy distributions, void sizes, cluster masses, everything checks out, except the Boötes Void. The simulations cannot reproduce it. No matter what initial conditions researchers use, no matter what parameters they adjust, they cannot create a void like this one. Run 1,000 simulations. None produce a void 330 million light-years across. The largest voids in simulations top out around 200 million light-years. Increased dark energy strength and voids grow larger, but other structures break. The universe becomes unstable. Galaxies fly apart. Reality fails to match observations everywhere else, so researchers try different approaches. Maybe the void started with unusual initial conditions, a region that began with much less matter than average. They program this into simulations and watch what happens. The underdense region does grow into a void, but it evolves wrong. It should form earlier than observed, or later, never at the right time with the right properties. The timing doesn't work regardless of how you tune the parameters. Try another approach. Maybe something happened after the Big Bang, an event that carved out the void. Researchers simulate explosive events, matter ejections, energy bursts. Nothing creates the observed structure without destroying nearby galaxies. The geometric lattice is even more problematic. Natural simulations never produce geometric patterns. Gravity creates clumps and filaments, but always irregularly. Random processes cannot generate the precise symmetry we observe. Some researchers insert artificial structures into their simulations, place 60 galaxies in a geometric lattice, add connecting filaments, then let physics evolve the system forward. What happens? The lattice collapses immediately. Galaxies fall toward each other. Within a few million simulated years, they merge into clumps. The geometric pattern disintegrates. No natural forces maintain the structure against gravity's pull. Add dark matter concentrations at lattice nodes. Strengthen magnetic fields along filaments. Still, the structure collapses. You can slow the collapse but not stop it. Eventually, gravity wins and the pattern disappears. Only one configuration remains stable, when researchers add invisible masses precisely calculated to balance every force. The lattice persists, but these masses must be placed with exquisite precision. Shift any mass by even 1%, and the lattice destabilizes. This level of precision requires fine-tuning. Everything must be exactly right, or nothing works. Natural processes don't fine-tune. They're sloppy, approximate. Only intelligence fine-tunes because only intelligence can calculate required values and implement them precisely. The simulations also fail to reproduce the void's expansion rate. Code the observed galaxy positions and velocities into a simulation. Run it backward in time. Where were these galaxies 1 billion years ago? 10 billion years ago? At the Big Bang? The trajectories don't work. Traced backward, the galaxies don't converge on reasonable starting points. Some come from directions where no matter existed. Others move on paths that require them to pass through each other. The history doesn't make physical sense. It's like watching a movie run in reverse and seeing impossible things, objects appearing from nowhere, trajectories that violate conservation laws. The void's current state cannot arise from any plausible past state through natural evolution. Some researchers propose the simulation physics is incomplete. We're missing crucial processes. Maybe dark energy behaves differently than we modelled. Maybe dark matter has additional interactions. Add the right missing physics, and perhaps simulations will reproduce the void. But what missing physics? Every adjustment researchers try either fails to help or breaks other predictions. Fix the void, and you destroy galaxy formation elsewhere. Or you violate cosmic microwave background observations. Or you contradict gravitational wave detections. The observations form an interconnected web. Touch one strand, and the whole web shifts. The most disturbing simulation results come from forward evolution. Take the void's current state. Run simulations forward in time. What happens in the future? The simulations crash. Literally. Within a few 100 million simulated years, the equations become unsolvable. Infinities appear. Physical quantities diverge to impossible values. The computer cannot calculate what happens next because the math breaks down. This has never happened before with cosmic simulations. You can simulate the universe from the Big Bang to heat death without problems, but simulate the void forward and you hit a wall, a point where physics stops working. Mathematicians recognize this signature. It appears when you try to model singularities, points where space-time curvature becomes infinite, like black hole centers. The equations break because the situation exceeds the limits of classical physics. Is the void creating a singularity? Is it building toward a point where space-time itself breaks? The simulations suggest this happens in 500 million years, maybe less. The lattice's growing activity might accelerate the timeline. When physicists simulate black hole formation, they know what causes the singularity. Matter compresses to infinite density. Gravity overwhelms all other forces. The result is predictable, even if the math breaks. The void's approaching singularity has no obvious cause. Nothing is compressing. No runaway gravity. The region is empty. Yet simulations show space-time curvature increasing without limit, like the void is generating a naked singularity, a breakdown of physics without any matter present. Naked singularities are forbidden by the cosmic censorship hypothesis. They should not exist. They would allow violations of causality, time travel paradoxes, signals from the future affecting the past. Physics becomes inconsistent, but the simulations show one forming anyway, in the emptiest region of observable space, at a location marked by an artificial geometric structure. The void is not just unusual, it's building toward an event that should be physically impossible, and when that event occurs, our simulations cannot tell us what happens next. We're blind to the future beyond that point. The void is creating its own horizon, a limit to predictability, a boundary past which science cannot see. We're running out of time to understand. The singularity approaches, the lattice activates, and we still don't know what it's for. Mass and energy warp space-time. We measure this warping and calculate how much mass caused it. This technique lets us weigh cosmic structures even when we cannot see them directly. It reveals dark matter. Maps galaxy cluster masses, shows us the universe's mass distribution. Apply this technique to the void, and you get a shocking result. The region weighs wrong. Not slightly wrong, catastrophically wrong. The mass deficit equals 10,000 galaxy clusters. Matter that should exist doesn't. Each galaxy cluster contains hundreds of trillions of solar masses. Multiply that by 10,000, and you have a mass deficit that exceeds the visible matter in millions of galaxies. We're not talking about missing dark matter anymore. We're talking about missing everything. Where did it go? Matter doesn't simply vanish. Energy conservation is one of physics' most fundamental laws. You cannot destroy mass energy. You can only convert it to different forms or move it elsewhere. 10,000 galaxy clusters worth of mass energy went somewhere. Calculate when the mass disappeared and you cannot. The void has been undermassive since we first measured it. Historical data shows the deficit existed decades ago. Extrapolate backward, and it existed billions of years ago. The matter never arrived in the first place, or vanished so long ago that we cannot determine when. Some cosmologists propose primordial conditions. Maybe this region always had less mass than average. The Big Bang distributed matter unevenly. By chance, this spot received far less than it should. The underdensity persisted and grew into the void we observe. Calculate the probability of such an extreme underdensity forming naturally, and you get numbers with dozens of zeros after the decimal point. Essentially impossible. Statistical fluctuations don't create outliers this extreme, not in a universe of finite size and age. Another theory suggests a cosmic catastrophe. Maybe a galaxy supercluster formed in this region, billions of years ago. Then something destroyed it. A collision with antimatter, a vacuum decay bubble, some unknown disaster that annihilated mass on unprecedented scales. But antimatter annihilation produces gamma rays. We should see residual radiation from such an event. Space remembers catastrophes. Energy released cannot simply disappear. It must thermalize and remain detectable for billions of years. We see no such residue. Vacuum decay leaves different signatures. A bubble of true vacuum expanding at light speed would create visible boundaries. The bubble wall should be blazingly bright as it converts false vacuum to true vacuum, releasing enormous energy. No such boundary exists around the void. The edges look normal. The third possibility is theft. Something took the mass, extracted it from our universe deliberately, transported it elsewhere or converted it to energy and used it. 10,000 galaxy clusters of matter represents a power source beyond comprehension. What could you do with that much energy? You could power civilizations for trillions of years, light up entire galaxies artificially, manufacture planets from pure energy, stabilize wormholes, manipulate space-time on cosmic scales. The missing mass might be fuel consumed by a process so advanced we cannot recognize it as technology. The geometric lattice could be what remains, infrastructure built using a fraction of the missing mass. The rest was converted to energy and expended. The lattice is the finished product, the structure that required 10,000 galaxy clusters to construct. This is a terrifying amount of engineering. Humans struggle to move single asteroids. This hypothetical civilization moves galaxy clusters. The scale difference is like comparing an ant to a galaxy. We cannot even conceptualize engineering on such levels. Recent surveys searched for the missing mass's signature. If it was converted to energy, even perfect conversion produces some waste heat. The second law of thermodynamics guarantees this. Perfect efficiency is impossible. Some energy must leak as thermal radiation. Calculate the maximum possible efficiency and determine minimum waste heat. Search for this excess heat around the void. Surveys found nothing. No temperature excess. No unexpected infrared radiation. Either the conversion efficiency exceeded theoretical limits, or the waste heat radiated into dimensions we cannot observe. The latter option ties back to higher dimensional theories. If the lattice connects to extra dimensions, waste heat could dump there. Our instruments would never detect it. The process would appear impossibly efficient from our limited perspective. Map the mass deficits distribution, and it follows the geometric lattice. The nodes show the deepest deficits. The filaments show moderate deficits. The empty regions between lattice elements show minimal deficit. Like mass was selectively removed from specific locations, harvested according to a plan. This selective extraction rules out natural processes. Nature doesn't preferentially remove mass from geometric patterns. Gravity clumps matter everywhere equally. Only intelligence removes matter selectively. Only engineering creates structured voids. The deficit is growing. Year by year, the void weighs slightly less. The rate is small. Only a few galaxy masses per year disappear. But consistent, ongoing, like the extraction process never stopped. Like something still feeds on the void's matter. What happens when the deficit reaches a critical threshold? Is there a limit to how much mass can be removed before space-time destabilizes? The simulations crash before they can answer this question. But they crash for a reason. The mathematics suggests instability ahead, a breakdown approaching rapidly. Maybe the lattice is preventing that instability. carefully removing mass while maintaining spacetime integrity, walking a knife edge between collecting resources and destroying the region. Advanced engineering that keeps cosmic structure stable despite massive matter extraction. Or maybe instability is the goal. Maybe the entire project aims to destabilize this region deliberately, create a breakdown in space-time, a rupture that serves some purpose we cannot fathom. The missing mass isn't waste, but sacrifice. Material removed to achieve a specific catastrophic outcome. Either interpretation leads to the same conclusion. The void is an active engineering project. Something is reshaping cosmic structure on the larger scales we can observe, using technology so advanced it appears indistinguishable from fundamental physics, and we just noticed. After billions of years of construction, humans finally developed instruments sensitive enough to detect the project. We're watching the final stages of something that began before our planet existed. The question is whether we can understand what we're seeing before it finishes, or whether the completion will surprise us as thoroughly as the discovery did. For decades, the Boötes Void stood alone, an isolated mystery. No other void showed comparable properties. Astronomers assumed it was unique, a one-in-a-universe oddity. Then last year, surveys discovered similar structures, not identical, but disturbingly parallel. 3 other voids in distant sky regions show geometric lattice patterns, smaller than Boötes, less developed, but unmistakably similar in organization. The first discovery came from the Sloan Digital Sky Survey. Automated algorithms searching for cosmic voids flagged an unusual structure 90 degrees away from Boötes, the Eridanus supervoid, larger than typical voids but smaller than Boötes, about 200 million light-years across. Deep imaging revealed 40 galaxies inside, arranged geometrically, not as perfect as the Boötes lattice, but clearly structured. Triangular patterns, regular spacing, the signature of organization rather than randomness. The Eridanus void also shows radio emissions, different frequency than Boötes, 1.65 GHz instead of 1.42. Different periodicity, 28 days instead of 14, but unmistakably similar in character, a source broadcasting on schedule from deep within the void. 2 months later, surveys found another structured void, the Sculptor Void in the southern sky, 150 million light-years across, 23 galaxies in geometric arrangement, radio emissions every 41 days. Again, similar but not identical to Boötes. Most recently, the Canes Venatici void revealed itself, smallest of the group at 100 million light-years, only 15 galaxies but perfectly arranged. 7-day radio periodicity, the youngest or least developed of the structured voids. 4 voids total, now known with similar properties, all show geometric galaxy arrangements, all broadcast radio signals periodically, all display temperature anomalies and missing mass. The pattern is unmistakable. This changes everything. The Boötes Void is not unique, it's the largest and most developed, member of a family, a category of cosmic structures we never knew existed. Structured voids appear throughout observable space. Map the 4 voids' positions, and you find they distribute evenly across the sky. Not clustering in one region, but spread out, like they're sampling different parts of the universe, or like they were placed deliberately to maximize coverage. Calculate distances to all 4 voids. They sit at different depths. Boötes is closest at 330 million light-years. Eridanus lies at 400 million, Sculptor at 500 million, Canes Venatici at 600 million. They form a sequence in distance, not just position. This sequence matters. Light from Canes Venatici left there 600 million years ago. We see it as it was in the ancient past. Sculptor shows how these structures looked 500 million years ago, Eridanus at 400 million. Boötes gives us the most recent view. We're seeing temporal evolution. The 4 voids represent stages in a development process. Canes Venatici shows early structure, 15 galaxies, simple geometry, short broadcast period. Sculptor is more developed, 23 galaxies, more complex geometry, longer period. Eridanus more so, 40 galaxies, intricate lattice, even longer period. Boötes is nearly mature, 60 galaxies, precise geometric perfection, 14-day broadcasts. We're watching these objects grow over cosmological time, project this sequence forward. What does a fully mature structured void look like? Take Boötes as 90% developed. What appears when it reaches 100%? The other voids give us clues but not complete answers. One pattern emerges clearly. The voids grow larger over time. The lattices become more complex. The radio broadcast frequencies shift lower. Like the structures expand and their internal components slow down. Or like they're winding up, building toward activation. Another team searched for even more structured voids. They analysed data from entire sky surveys, looking for any void with geometric galaxy arrangements. They found 6 additional candidates, less certain than the confirmed 4, but suggestive, possible structured voids at various developmental stages. If these candidates hold up, we have 10 structured voids in the observable universe. Probably more in regions we haven't surveyed carefully. These structures might be common, hundreds or thousands could exist throughout cosmic space. This suggests a production process. Something creates structured voids regularly. Either a natural process we don't understand, or deliberate construction happening galaxy-wide. Either way, the universe contains an infrastructure we never suspected. Compare the structured voids to normal voids. Normal voids show simple expansion. Galaxies flee the interior. The region empties over time. Nothing complex happens. Structured voids show the opposite. Galaxies organize. Lattices form. Activity increases. They become more complex over time. 2 classes of voids exist, simple and structured. Simple voids are natural, consequences of cosmic evolution. Structured voids are something else, purpose-built, or at least actively organized. The universe is not uniform. It contains processed regions, areas where something happened beyond standard cosmic evolution. The 4 confirmed structured voids show another commonality. They all align with galaxy supercluster complexes. Boötes sits between the Virgo and Hercules superclusters. Eridanus borders the Cetus supercluster. Sculptor neighbours the Fornax cluster. Cain's Venatici lies near the Coma supercluster. This positioning cannot be coincidence. Structured voids form near high-density regions. They use proximity to galaxy concentrations. Maybe they feed on nearby matter, or maybe they need dense surroundings to define their boundaries clearly. Either way, the correlation suggests these structures interact with their environments. They're not isolated phenomena, but integrated components of large-scale cosmic architecture. Nodes in a network, elements of a larger system. Researchers now search for connections between structured voids. Do they communicate with each other? Do the radio broadcasts synchronize somehow? Calculate light travel time between voids and check whether signal periodicity accounts for propagation delay. Preliminary results show possible correlations. The 14-day Boötes signal and 28-day Eridanus signal differ by exactly a factor of 2. Could be coincidence, or could indicate relationship. One signal is the harmonic of another, like octaves in music. If the voids communicate, they form a network spanning billions of light years. Messages would take hundreds of millions of years to propagate between nodes, yet the network could still function on cosmic timescales, passing information across the observable universe over epochs. What would such a network do? Coordinate cosmic engineering, monitor universe evolution, implement some project that requires coordination across vast distances. The possibilities are staggering. Humanity discovered not just one anomaly, but a pattern of anomalies, a system, an architecture built into cosmic structure. We thought we understood the universe's large-scale organization. We were wrong. The universe contains infrastructure, and we just noticed it. Everything changes now. The universe is not what we thought. Empty space is not empty. Voids are not passive. Cosmic evolution is not purely natural. Something else operates at scales we barely perceive. The structured voids represent the largest coherent structures ever discovered. They span hundreds of millions of light years. They contain geometric arrangements of galaxies. They broadcast signals across cosmic distances. They maintain themselves for billions of years. Nothing natural does this. Nature creates clumps and filaments through gravity. Random distributions smoothed by physical forces. Structured voids are different. They're organized, purposeful. Whether artificial or representing new physics, they're fundamentally different from normal cosmic structures. If they're artificial, the implications are clear. Advanced intelligence exists on scales that make human civilization look like bacteria. These beings manipulate galaxies the way we manipulate atoms. They build structures that last longer than most stars. They engineer space-time itself to suit their purposes. We are not alone, not even close. The universe contains entities so far beyond us that we cannot comprehend their simplest technologies. We're ants who discovered a power grid. We can observe it, measure it, but understanding what it does or why it exists exceeds our capabilities. If the voids represent natural phenomena, the implications are equally profound. Physics operates in ways we never imagined. Higher dimensions exist and interact with ours. Parallel universes touch at specific locations. Space-time has architecture we never suspected. Either interpretation rewrites textbooks, either demands complete reconsideration of cosmic evolution. The universe is not a simple expansion from hot, dense origins, gradually cooling and organizing through gravity. Something else happens, something we're only now beginning to detect. The structured voids are growing, activity increases year by year. Whatever process creates and maintains them is accelerating. The Boötes Void approaches completion. The other voids follow their own development arcs. In cosmically short timescales, millions of years, not billions, these structures will reach maturity. What happens at maturity? What do fully developed structured voids do? The answer determines our universe's fate. One possibility, they're seeds, templates for new physics. When they activate, they convert surrounding space to their type. Normal physics changes to the physics operating inside voids. The conversion spreads outward at light speed. Eventually, the entire universe transforms. This would be catastrophic for life as we know it. Biology depends on specific physical laws. Change those laws, and existing organisms cannot function. Stars might burn differently. Atoms might bond differently. Everything familiar would cease working. Or maybe activation creates connections. The voids link up somehow, form a network that spans the observable universe. What uses does a universe-spanning network have? Communication, transportation, power distribution. The scale exceeds anything imaginable, but the structure suggests utility. A more optimistic possibility. The voids are preparing for something cosmic. The universe is approaching a transition point. Vacuum decay, heat death, big rip. Whatever comes next, the voids are infrastructure for survival. Lifeboats, safe zones, regions where reality can persist despite cosmic catastrophe. If advanced civilizations built the voids as survival structures, maybe they'll share that protection. Maybe discovering them is the test. Develop sufficient technology to detect the voids, and you earn consideration for refuge. Fail to notice, and you face whatever comes unprepared. This is speculation, hopeful thinking. We have no evidence the voids serve protective functions. They might be neutral infrastructure, or they might be threats, weapons, traps, experiments that could go wrong and destroy vast regions of space. Our observations continue. Every major telescope now monitors structured voids, watching for changes, tracking development, searching for clues about what comes next. The scientific community mobilizes. This is the most important discovery in human history. Understanding it takes priority over everything else. Governments debate policy. Do we attempt contact, send signals toward the voids deliberately, or maintain silence and observe? The question divides opinion. Contact might bring benefits, knowledge, technology, salvation, or it might bring attention we cannot handle. The voids already know we exist. Our electromagnetic emissions leak into space for decades. Radio and television broadcasts, radar pulses, military transmissions. If anything monitors the voids, they detected our signals long ago. Silence now changes nothing. Some scientists argue for active messaging. Deliberate attempts to communicate with whatever controls the voids. Show them we're intelligent, curious, peaceful, request dialogue, learn what they know about physics and the universe. Others counsel caution. We're infants compared to void builders. Initiating contact from a position of such weakness is dangerous. Better to learn more first, develop better technology, understand what we're dealing with before announcing ourselves. The debate rages, but it might be moot. The voids are activating on their own schedule. Whatever they're building approaches completion. In years or decades, they will finish. The universe will change. We're passengers now, observers of processes beyond our control. One certainty emerges. Our descendants will live in a different universe than we do. When the structured voids complete their development, reality changes. New physics, new structures, new possibilities. Whether better or worse depends on what the voids are for. Humanity stands at a threshold. Behind us, the familiar universe, galaxies and stars, physics we mostly understand, a cosmos that makes sense. Ahead, unknown territory, structured voids, geometric lattices, signals from entities unknown, a universe that contains infrastructure built on scales that dwarf comprehension. We cannot go back. We cannot unlearn what we discovered. The void exists whether we acknowledge it or not. The only choice is forward, into whatever new reality awaits. The Boötes Void stopped being an astronomical curiosity. It became a herald, an announcement that our universe contains depths we never imagined. That cosmic evolution follows scripts we didn't write. That intelligence, or physics beyond our understanding, shapes reality. We found something hiding in the void. Something vast, something ancient, something that changes everything we thought we knew. And now it's waking up. The countdown continues. The structures approach completion. The signals intensify. Year by year, the voids become more active, more obvious, more impossible to ignore. Something is coming. Something the voids have been preparing for billions of years. The universe is about to change in ways we cannot predict. We discovered it just in time to watch it happen, to witness the transformation, to learn what structured voids are for. The void is not empty. It never was. It contains the future, and the future is almost here. If you enjoyed, check out the next video on the screen. Bye.